wonderful viewers. You're welcome to Dr. Buchi on Purpose YouTube channel. My name is Dr. Buchi of Haematology and Blood Transfusion Science Specialty. Please, if you're new here or you're a returning viewer and have not subscribed to this channel, please do well to hit the subscribe button. And don't forget to hit the notification button as well to get alerts on the next video upload. So today we'll be talking about different types of mutations. Now, in an organism, a change which occurs in the DNA sequence is known as mutation. This happens as a result of replication errors in the DNA at the end of cell division. Therefore, it is that alteration that occurs in the genetic material, the genome of the cell. My name remains Dr. Buchi. You're welcome to my YouTube channel. Today we'll be on mutation and types of mutations. Let's get started. In genetics, we have the nucleotide mutation and the chromosomal mutation. They have different subtypes. The body grows from cells to tissues to organs to systems before they begin to exhibit different functions. Now, the cells has nucleus, and this nucleus consists of the DNA, which is made up of ribose, sugar, phosphate, and nitrogenous bases. The DNA undergoes mutation in sequential bases of A, C, G, and T. These changes occur during DNA replication if mistakes and errors occur along the line, but in some cases alterations can happen as a result of exposure to environmental factors like radiation, sunlight, and smoking. Cells have the prowess and powers to recognize potential alterations that cause damage or can fix and repair them before they turn out to become permanent. Mutation can also and as well be inherited, like in the case of sickle cell anemia, which is a mutation in the gene. Mutation can disrupt normal genetic activity and then bring about cancer. Knowing that DNA consists of ribose, sugar, phosphate, and nitrogenous bases. Now, when sugar is added to the nitrogenous bases, you will get a nucleoside. And when phosphate is added to these two, you will be getting a nucleotide. Mutation on nucleotide is known as nucleotide mutation. DNA is assembled into chromosomes. We have chromosomal mutation. So, since the alterations in DNA sequence, as I mentioned earlier, is mutation, nucleotide mutation can be silence, high sense, nonsense, insertion, or deletion, while chromosome mutation can be deletion as well, duplication, inversion, insertion, or translocation. The silent, the high sense, and the nonsense in nucleotide mutation are referred to as point mutation, whereas insertion and deletion in the same nucleotide mutation are referred to as frame shift mutation. In nucleotide mutation, nonsense makes stop codon like the UGA, UAA, or the UAG. In silence, which is under the nucleotide mutation, at the point mutation wing, there is no effect on the protein. For instance, if we had TTA to be changed into TTG, what then will TTA be coding for rather? Of course, it will be coding for leucine. And what will TTG be coding for? Of course, leucine as well. So here, there is no effect on the protein. Now let's look at the high sense. In high sense, there is substitution, for example, where there used to be glutamine and you now have valine, just as the case of sickle cell mutation. The result is that the red blood cells become abnormally shaped, sickled, rather than the normal biconcave shape. The advantage of this replacement is that malaria cannot live on this type of red blood cells. But the bad situation is that the red blood cells are clogged in vessels and can bring discomfort and crisis. In nonsense, this is a stop codon. For instance, you have UGG and it becomes UGA. This is the stop codon, just as the name implies. It rather stops nonsense. Don't mind me. In insertion and deletion, they can bring about frame shift mutation. Just for example, we have ATG, TTA, CCT, and if ATG gives you methionine and TTA gives you leucine and CCT gives us proline, and for a certain unknown cause, a T in the TTA gets erased, maybe because of deletion, then ATG will still give us methionine. And in the case of TTA, where one T was actually deleted and we now have TAC in replacement, which does not code for leucine but for tyrosine. This mutation is the frame shift. Now we are looking at we'll be looking at duplication. In duplication, this is the case of where there used to be one sequence and you now have 2x. It is double, or 3x, it is tripled, or 4x to become quadruple. In the case of inversion, the DNA sequence here is reversed. It is a case of where one used to be this and now it is no longer that, but something totally different, something else. Now looking at the photo on the screen, there is the replacement of purple and green band on the two representing bars, which are the chromosome representative. In insertion, looking at the photo on the screen, there are two representing chromosome band around the insertion column. Now the first one had the red part, but the second one did not. Then the first gives out its piece and inserts it into the second one. This is insertion. In the case of translocation, there is exchange in form of give and take process, and then if a chromosome has a feature and then another chromosome has another feature, and the exchanges feature, then translocation will take place. At this point, I would like to come to the end of this particular video here. Until we meet next time to talk about mutation part 2, I would like to say goodbye. Thank you for staying through to the end. See you next time. For now, stay safe and remain woke. Bye.
Hello viewers, you're welcome to Dr. Buchi and Purpose channel. Here I create comprehensive, easy to grasp lectures for students and non-students. My lectures are detailed and easy to assimilate. I also share useful academic information, career, job opportunity tips, lifestyle, and health talk. If there are topics you want to be discussed here, please do well to mention on regular basis.